Well, now we're going to actually use Excel to perform some calculations that are associated with descriptive statistics. In this case, I'm working with a sample. The sample consists of 18 values, 18 numbers. That they could represent test scores, they could represent blood pressures. In our case, we're not really that interested in what they actually represent because we want to demonstrate using SPSS Excel to evaluate and to describe this range of numbers. Okay, so for starters, when I look at this set of numbers, I say to myself, I'm really interested in knowing where the middle is so I can describe the average value for this sample of people, let's say, and I also want to know something that'll represent the variability, how much difference there is between each of the values here. Are they tightly clustered or are they all spread apart? So I'm going to invent a couple of ways to describe that. One way for me to describe the center of this distribution or this sample is the mean. And I'm going to go click down here, and as it happens, I know that there's a function built into Excel called average. So I'm going to use that, equals average. Now notice as I fill it in and put in my first parentheses, okay, that it gives me a hint here. It wants me to fill in the numbers that are represented by that average, or at least the cells of those numbers. Okay, so I can either type in A2 through A19, or I can just, as I'm in this position, just click in and drag down, and it fills it in for me. And then put a close parentheses and hit enter. So the average for this population, or this sample, is 99.94. In other words, X bar is 99.94. Okay, so if I wanted to, I could have instead calculated the sum and divided by the count. Notice there is a count here, and there's a function in Excel that says count. Parentheses, and I'm going to ask it to do a count for all of these numbers as well. And indeed, there are 18 values here as well. Okay, so now I'm interested in finding the variability within these values. How different are each one of these values from the middle value, 99, or close to 100, actually? How different are each one of these values? Okay, so I'm going to go in here and I'm going to say, I'm going to copy this value into this location. Okay, so I'm going to say that this location is equal to this value. Okay, and then I'm going to say to myself, I want to copy that value all the way down. So I'm going to click in there. Now, there's a number of ways I can do this. One way is to do this and say fill down. Oh, well, what happened here? Something went wrong, didn't it? Well, what happened is looking next to this, it looks like it's doing a calculation with the adjoining column. So it actually took this first value, which was B21, which was echoing, in other words, this one's equal to B21. The next one, it said, must be B22. Remember how we did that calculation earlier with side-by-side columns? And this one is B29, these are all empty values. That's why those zeros all came up. So I need a way to copy this down without doing that step-by-step conversion to because Excel thinks we want to step down through different adjoining cells. So one way to do that is to put dollar signs in front of the B and a dollar sign in front of the 21. That changes it from what's called a relative reference to an absolute reference. So from now on, when I copy this box down, it'll just copy exactly what's in the box. Okay, or 99.944 and so on. Okay, so this is the mean. So one way for me to judge how different each one of these values is from the mean is to just take each individual value, in this case 99, subtract the mean from it, and just see the difference. Okay, there's a difference for this first value, And I'm going to do that for each one of these other values as well. Okay, some of them are large, some of them are small. If I wanted to get an idea of the overall variability of these values from the mean, how different are they from the mean, one of the things I might be interested in doing is adding them all up. So let's see what happens if I do that. The sum of all of these values. Okay, when I add them all up, well, it's 2 times 10 to the minus 14. That's basically essentially 0. Okay, what happened there? What happened there is that all these values, the positive and negative numbers, all canceled out, right? Why did that happen? Well, isn't that kind of what the mean represents? It represents an arithmetic average for all of the values. So if I look at all the differences, they should really be even. Now, one of the things I can do also is I can make this a little easier to read by formatting these cells so that they round off. So I'm going to round these off to 1 decimal place. Okay, that makes this a little bit easier to deal with. Now, keep in mind, though, that the actual values are preserved by Excel. We haven't changed the number. In reality, we just displayed it differently. Okay, so now I can't add these together without getting 0. So maybe there's another way I can demonstrate how big these differences are from the mean, whether they're big differences or small differences. How variable are they? Okay, so there's a couple of ways I could do that. One way is to just take the absolute value for all of these numbers, which is just drop all the minus signs, right, and add them together and see how big a number I get. Another way to eliminate negative signs is to square a number. Anytime you multiply a negative number times a negative number, you get a positive number. Well, let's give that a try. Equals this number times itself. Okay, and in fact, it now is squared. Okay, so that negative number goes away. So now I'm going to copy these values down. Okay, and there's all my values copied down. And notice now I don't have any negative numbers anymore. So I'm going to add up the sum of those, of all of those squares. And the total comes out to be 892. Well, that's very interesting. The bigger this total is, the bigger the variability of the values is. Does that make sense to you? In other words, if there's not much difference between the means in each of these values, then the difference, x minus x bar is the mean, the difference between the mean and each value is going to be small, the square is going to be small, and the total of the sums of the squares is going to be small. Okay, now if there's a lot of variability, this number gets bigger. Okay, so this number is referred to as the sum of the squares of the differences between the values and the mean. Okay, well, we abbreviate it and just call it sum of squares for the most part. So this is a measure of how variable these numbers are. Well, now, just like the average before, I want to take a look at this in terms of what the value is per individual. So normally what I would do, I'd say, let's take that number, just like we did with the mean, put an equal sign in here, take that number and divide by the number of values, 18. As it happens in statistics, we'll talk about this later on in the semester, we'll be dealing with a concept called degrees of freedom. Instead of using 18, we use 18 minus 1, 17. Okay, so I'm going to put 17 in there, divide by 17, and I get an average sum of squares, which is 52.5. We have a special term for that in statistics. We call that the variance. Now, the other problem we have now is that relative to these differences, that's a very large number, right? And the reason why it's a very large number is because we squared all of the differences. So now let's bring that number back down into the magnitude of numbers that we started with by simply taking equals, taking the square root of it, and as you would suspect, there's a function for square root. Parentheses. Okay, whoops, I misspelled it. You could tell it was wrong because I didn't get my little hint down at the bottom there. Right, square root just wants a number. Square root of this number happens to be 7.2. That value, 7.2, is a special number that's referred to as the standard deviation. That's going to be important to us as we move forward during the semester. Okay, so now the other values that I can find, for instance, that we might give us an idea of the spread and the median, the middle of this value, is the minimum. And in fact, there is a function minimum, right? And I could take the minimum of all of these values, and the minimum value is 88. I can take the maximum. Okay, the maximum value of all of these numbers is 114. The range is the maximum value minus the minimum value. Similarly, I can take the percentiles of these numbers, especially important percentiles like the 25th and the 75th percentile, which help us draw a box plot if we want to. Okay, so I'm going to go ahead here and I'm going to calculate the percentile. And again, there happens to be a function, percentile. Right? I'm going to put parentheses in here, and it helps me out. An array, comma, k. K represents the proportion, which is the percentile you're interested in. And in this case, let's see, the array is this group of numbers here, comma, and the percentile for the 75th percentile is 0.75. Okay, so the 75th percentile is 104. I'm going to repeat that again for the 25th percentile. Okay, and the 25th percentile is, let's see, the array, comma, 0.25, close parentheses, is 94.5, and the interquartile range, the middle 50% of this sample values, is going to be equal to 104 minus 95, or 94.5, which is 9.5. Now, if you were interested in the median, which is the middle value for all of these values, we also have a function here called median. Okay, let's see what the median is. And very often the median is very close to the mean. The mean is the arithmetic average. The median is the middle value. Okay, and in this case, the median is 100. It happens to be very close, in fact. Okay, and the median is just the middle value. If I were to take these numbers and sort them, watch me do this. Another function that we have in Excel. Okay, and if I were to go into here and tell it that I wanted to sort these numbers, okay, I'm going to sort them. Okay, the top number would be the smallest number, bottom would be the highest number. 2, 4, 6, 8, 9, and we got 2, 4, 6, 8, 9. We wind up with, these are the bottom 9 numbers. These are the top 9 numbers. Oops, did I do that right? 1, 2, whoops. 1, 2, 3, 4, 5, 6, 7, 8, 9. And these are the top 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there is no middle number. So our median would be the average between 99 and 101 because there is no middle number. So our average would be, let's see, actually I think it rounded it to 100. If I bet you if I went up here to our function again and told it I wanted that, oh, actually I'm wrong. The average between 99 and 101 is 100, so that is correct. Okay, so now, how do I know that these functions exist? Well, I've been working with this for many years, so I know that they're there, and I can communicate to you that they're there. But if you need some help with them, If you go to this little symbol f of x, which is a formula builder, click on it, and it will bring up a summary of all of the different functions that exist that are useful to you in Excel. And in fact, you can actually sort this. You can actually search for a specific function, or you can sort it on the basis of different kinds of functions, statistical functions, and so on and so forth. Okay, reference to the, let me see. Okay, and see if I can't find a, right now it's showing you, I can't get it to expand, showing the most recently used ones, but it also will display that, show you arithmetic functions, date and time functions, financial functions, so on and so forth. Then we scroll down far enough, we'll get to a list of statistical functions. Not quite yet. Here we go. Statistical functions, averages, distributions, confidence. We'll be using many of these functions as we work our way through the semester. Okay, but this is a brief introduction. Hopefully, by looking at this, I'm going to give you a simple example for you to work on as a quiz example, just to test your knowledge of Excel and give you a little bit of practice to actually dive in and do it yourself. There's no penalty for getting it wrong on the example, on the quiz example that goes along with this video. So I encourage you to download the Excel file that goes with it, in other words, the sample Excel file that I give you, and try to solve it on your own.